Hello everyone, in this video let's discuss about common collector configuration. If you are new to our channel, please subscribe for more engineering related topics. In previous videos we already discussed about common base and common emitter configuration. So the video link will be given in the description. So in this video let's discuss about common collector configuration. So the common collector configuration also we will be using the PNP transistor itself. PNP transistor. What is PNP transistor? One N type of semiconductor is doped in between two P type of semiconductor. So N type of semiconductor will have pentavalent impurities and P type of semiconductors will have trivalent impurities. So if we go through the examples of the trivalent impurities, it will be like aluminum. And for N type of semiconductor, that is pentavalent, example will be arsenide, gallium arsenide, like that. So in here also we are using the PNP transistor, and here the collector is common. Collector is common in between input and output. Collector will be common in between input and output. So if we consider the circuit, so I said collector will be common. So collector, so this will be called as the collector part. Next, this will be called as the emitter part, and this will be called as the base part. So in the base part, the resistance will be called as base resistance. Next, voltage VBB. Next, emitter part VEE. Next, RE, that is the resistance because of the emitter. And how the current flows is from base to emitter, the current will flow in the collector configuration. So the direction of the current will be IE, that is the output current. Next, input current is IB. How we will know it is the output side or input side means, so we are taking the collector as the common, so this will be grounded, so its voltage will be equal to 0. The part which is in the left hand side will be called as the input side, and the part which will be in the right hand side will be called as output side. So whatever the current will be in the right hand side will be called as output current, left hand side input current. Left hand side voltage will be input voltage, right hand side voltage will be output voltage, like this. So this is the junction between base and the collector. So collector is the common now, so base and collector. So voltage will be VBC or VCB you can take. Now what will be the voltage between the collector and the emitter? So VCE. So it is the voltage between the collector and emitter junction. Now let's design the common collector configuration. Now first important thing we must define is the current amplification factor. Current amplification factor. So in common collector configuration, current amplification factor will be represented using gamma symbol. So gamma is equal to output current divided by input current. What is the output current? Output current means the current which is in the right side. So right hand side. What is the current in right hand side? That is IE. So IE will be output current, and input current means left hand side. What is the current? IB. So IE divided by IB will be the current amplification factor of the common collector configuration. Now let's plot the graphs for input characteristic and output characteristics of the common collector configuration. So first one is input characteristics. So we will plot this graph against current I and voltage V. So to draw the input characteristic graph, we need three values, that is input current and input voltage and output voltage. We need these three values: input current, input voltage and output voltage. So what is the value of input current? Input current means left side we must see. Input current is IB. Next, input voltage is, we must take the junction voltage, that is VBC. Next, output voltage. Output voltage means right hand side junction voltage. What is it? VCE. So now we are constructing the graph for the input characteristic. So this is only the output value we have. So we will make this as constant. So we will consider the output voltage as the constant value. Now let us increase the value of VCE from 0. So if I take VCE, that is the constant value as 2 volt. So there will be sharp increase in the current. So there will be sharp increase in the current when VCE value will be equal to 2 volt. Now as we increase the constant voltage value, that is let VCE is equal to 4 volt. So the same straight line, that is the current will rapidly increase in a straight line. Therefore the graph is shifting towards right. When the value of the constant voltage is increasing, the graph is shifting towards right. So right, shifting towards right or right side you read. Next, let's make the graph of output. Now let's plot the output characteristic graph of common collector configuration. So this will be also between current I and voltage V. So during construction of the output characteristic graph, we must need the values of output current, output voltage and input current. What we need? Output current, output voltage and input current. So output voltage means right hand side. What is the output voltage? VCE. What is the output current? IE. So input current means left side. So what is the input current? IB. So since we are plotting the graph of the output characteristics, so we will make the input one, that is input current as constant. This graph will be between output current, that is IE, versus output voltage VCE. So despite VCE cannot produce any current, but it will produce slightly small amount of current, that is called as ICE, which will be nearly zero. This IE we can call it as reverse leakage. Next, what are the values which are constant? That is input current. IB is constant. Now let's increase the IB value from 0. So if it is 0, no voltage will be produced. If current value is equal to, if current input constant IB is equal to 20 microampere. Let's take 20 microampere and another value as IB is equal to 40 microampere. So it will start from 0. When the voltage value increases, it will match the expected constant value. That is, when the voltage value VC value increases, so the constant value will be equal to the current produced. Next, in 40 microampere current also, it will match the 40 microampere current. It will be of the same constant level. So we have plotted the output characteristic graph. So the part where the current is diverting or the graph is diverting, we will call it as the active region. So the left out region from this side is called up to here. So we will call it as saturation region. In saturation region, there will be no deviation or the changes in the graph. Next, here where the current is not acting, we will call it as the cutoff region. So hope you understood the concept of common collector configuration. If they ask in exam, write the circuit, their properties and input and output characteristic graph. So that's all. If you have any doubt, please comment below. If you understood the video, please like and subscribe. Thank you.